mean, we all know that there is a vacuum in space. There are three major problems with getting humans into space, one of which is radiation, the other is temperature, but the main one is the vacuum. Now, everybody knows there is a vacuum in space, and basically what that means is there's nothing there. And the further away from Earth that you go, the International Space Station, which orbits at about 200 miles up, there's a vacuum surrounding that, but it is nowhere near as high as the vacuum that is on the moon. Humans are designed to operate in a pressurized environment. At sea level, we have 14.7 pounds per square inch pressing on us all around. Because we as humans can't survive in a vacuum, we have to take our pressure with us. What is the point about the vacuum being a key to this whole did we land a man on the moon? There are two things that happens in a vacuum, and one which affects photographic film is called outgassing. Because there is so little pressure, the volatile elements in the emulsion outgas. Now, we discovered that photographic film is affected by the vacuum of space. So how do we know that it's severely affected? About 2 years ago, I attended a talk in London given by the person who developed the photographic system used on the Hexagon Spy satellite, otherwise known as KH-9. The Hexagon Spy satellite used photographic film because prior to the use of digital, that was all that was available to take photographs in space of, in this case, Soviet rocket locations, Soviet warships. It was a very sophisticated camera. It had to be pressurized. And it was then I discovered that the film outgasses and it then can't be used, and also the film goes very brittle. If you use it even at relatively low pressurized environment, it affects the color balance of the film, and the color balance is shot to pieces. Now, as a result of that, we've decided to have a look at some of the effects of putting photographic film inside a vacuum chamber here on Earth. Photographic film, bottom left-hand corner, is comprised of a base material, which is normally a plastic polyester base, and various layers of photosensitive emulsion on top of it. The equipment that was being used produced a maximum Torr value of 10 to the minus 3, 100 kilometers, 62 miles above the Earth's surface. When you get to the moon, it's Torr 10 to the minus 12. Now on the right, there are two strips of film, photographic film, which indicate the effect that vacuum has at that level, Torr 10 to the minus 3. And it affects the photographic film. More importantly, it affects the color balance of the film as well. When a photograph is taken using film that was within the vacuum chamber, that will be on the right. The control film was on one on the left. The color balance of the film is shot. And this is Torr 10 to the minus 3. It's really not very far in space.
When I started researching this, there was two aspects of the Apollo missions that really stood out for me. The first one was the Apollo guidance computer and its navigation system. The second was the F1 engines. The F1 engines were the most powerful engines ever built, and were only used during the Apollo moon missions. They were never used after that. That whole program was ended after the Apollo mission, the last Apollo mission in 1972. These engines were developed specifically to lift the enormous amount of weight of the Apollo hardware into low Earth orbit. They were needed to get the rocket off the launch pad. Without the F1 engines, that could not have happened. There is no way that they could have lifted that hardware off the launch pad. And if you can't do that, ergo, you have no Apollo moon missions. So they were having some problems with the F1 engines. The main problem they were having is a thing called the combustion instability. What that really means is, so you have the engine, and then you have the fuel injection system, then you have the combustion chamber, and then you have the throat, and then of course you have the nozzle. So what was happening with the combustion chamber, the F1 engines, is the temperatures were reaching so high, up to 6,000 degrees Fahrenheit, that the cooling system was having a problem maintaining lower temperatures, because if you could not lower those temperatures and keep them constant, just the enormous amount of heat produced in the combustion chamber from the explosion of the propellants was going to distort and then eventually lead to an explosion and of course loss of the engine. And if that engine was of course used on a Saturn V, then you have the loss of the whole mission. It was when they got to the second version of the H1 engine that they realized that they were having the same problems with the F1 engine was having, and that is they used the same system, it was the same regenerative cooling system, the small tubes that were placed outside of the nozzle and the combustion chamber to absorb the thermal energy of the high temperatures, which could reach up to 6,000 degrees Fahrenheit. Interestingly enough, the H1 engine was using the same material as the F1 engines for its cooling system, and that was the nickel alloy that I had just mentioned. So what did they do? They solved the problem. And how did they solve it? They solved it with eliminating the use of the material that they were using for their cooling system in the H1 engine, and went back to using stainless steel instead. And then the engine worked perfectly. However, that wasn't done with the F1 engines. They had to stay with the original material they were using, which was constantly breaking down due to erosion. And that's where it sort of rears its ugly head. But it was the second launch, Apollo 6, where they had serious problems with the F1 engines. The Apollo 6 F1 engines were firing unevenly because of the combustion instability. And because they were firing unevenly, they were sending a resonance through the longitudinal axis of the rocket, which was causing a thing called pogo. So you had a pogo effect.
In this photo, you can clearly see that there are two objects present. And in this photo, you can see that those two objects are present and a little closer. However, in this photo, how are those two objects apart now? In the SLRO photo, you can see that our CGI truck has now moved from point A to point B, at least 150 feet away. This is Object A and Rock 1. And in this photo, you can clearly see that Object A has moved. And in this photo, you can see that Object A has clearly moved at least 155 feet. How is this possible if this photo was really taken on the lunar surface?
Yes, that's one interesting video, I must say. People have argued that it isn't really a truck. I don't know how rocks that look like trucks on the moon can actually move around like that. I've studied all of the images from NASA, anything related to that photograph, and it doesn't matter what angle you're looking at it at, those rocks have moved. And I think as they were faking the missions, I think they got lazier, sloppier, more carefree. And I do believe that the astronauts were the whistleblowers and they were using those Hasselblad cameras to expose the fraud. NASA has always given you that image of what the lunar surface is to look like. The image of the ground, the rocks, everything that should be on the lunar surface. I don't believe that that's like that at all. The lunar surface is absolutely pristine, untouched. There's no rain, there's no air, there's no wind, there's no ice, there's nothing going on there other than the meteor impacts. It's just continuously being covered by cosmic dust. If this is an actual set on the moon, and of course you're in a vacuum, and there are no liquids in a vacuum, of course here you can clearly see that it is. I've seen people argue that that is just a shadow, or that's just the way nylon reflects. They were using the same rover for all of the missions. The left rear axle has a leak in it, and the oil is spilling out everywhere all over the side of the rim, as well as running up to the side of the frame rail. They also showed this same rover with the same oil leak in 15 and 16 as well. And of course, again, no liquids in space. This is an image of non-metallic materials coming out of a vacuum chamber, and the maximum, of course, they could pull is a torr value of 10 to the minus 6. On the top left side are the original before they went into the chamber, and the other ones are showing the effects of the non-metallic materials. Some of these materials in here are what compiled in making photographic film, polymer acetates, Teflon, and Mylar, and all of them are damaged from the vacuum on it. One of the other effects that they were looking at in there was UV radiation exposed to that. And of course, when you're outside of the Earth's atmosphere, you don't get any diffusion of that, and you're getting the full spectrum of the sunlight.
Alas, we did not go to the moon, It's one more in a series of mass illusions where you three are among the champions in exposing the full dimensions of the hoax. This is Jim Fetzer, your host on The Real Deal.